You know that feeling, right? That little pit in your stomach when you realize the app that runs perfectly on your laptop, well, it might just completely fall apart in the real world. So today, we're going to bridge that gap. We're taking your code from the cozy comfort of your local machine and launching it into the wild, unpredictable world of production.
See, on your own machine, everything's perfect. You're the only user, the network is flawless. You're in total control. But production? That's a whole different beast. We're talking thousands of users hitting your app at once. The network is, well, it's a mess, full of latency, dropped packets, you name it. It's not just a gap, it's a canyon we have to cross. So, the big question is, how do we get across safely?
All right, first things first. Before we even dream of deploying, we've got to get our app in shape. Think of this next part as your pre-flight checklist before going live.
Okay, these three things, they are absolutely non-negotiable. Number one, secure your keys. Seriously, hard-coding API keys is just asking for trouble. A total recipe for disaster. Number two, expect failures. Your code is going to break, that's a guarantee. The trick is building it to recover gracefully. And finally, number three, add a dashboard. You've got to have eyes on your app because you can't fix what you can't see.
So let's talk about securing those keys. It's super simple, but so important. Instead of just typing your API key right into your code, which is a huge no-no, you use something called an environment variable. You set the key in your production environment, and then your code just pulls it in safely using os.getEnvironment. The best part? Your secret keys never ever end up in your Git history where anyone could find them. It's such a simple habit to get into, but it is absolutely critical. Now for my favorite part, building for failure. This little @retry decorator you see here, this thing is your secret weapon against all those random temporary glitches. It uses a really clever strategy called exponential backoff. So, if a connection fails, it doesn't just try again immediately. Nope, it waits a second. Fails again, it waits 2 seconds. Then 4, then 8. It gives the other service a chance to breathe and recover, instead of you just hammering it over and over again. It's brilliant. Okay, so your app is prepped, it's resilient, it's ready to go. Now for the fun part. How do we actually get this thing online? There are basically 3 main roads you can go down, and each one has its own pros and cons. I like to think of it like choosing how you're going to get around town. Serverless? That's your zippy little scooter. It's super fast, super easy to just hop on and go. Perfect for quick trips. Docker is like your trusty car. It's flexible, it's reliable, it'll get you pretty much anywhere you need to go. And then you've got Kubernetes. That's the freight train. It's unbelievably powerful and can haul a massive load, but, it takes a bit more work to get it rolling. Let's start with serverless. With a platform like Vercel, you literally just write a tiny little config file like this. You just tell it how to build your project and which route to use. And that's it. You hit deploy and you are live. It is, without a doubt, the fastest way to get your code from your machine to a public URL that people can actually use. Okay, next up, Docker. A Docker file is basically a recipe. It tells Docker exactly how to build a neat little package of your app, a container. And the magic of this container is that it runs exactly the same, no matter where you put it. Your laptop, a server in the cloud, wherever. It finally, once and for all, solves that classic, infuriating problem of, but it works on my machine. And finally, the big one, Kubernetes. Now, I know it can look a little intimidating, but at its heart, it's all about one thing, reliability at scale. See this one line here, replicas 3? That's you telling Kubernetes, hey, I always want 3 copies of my app running no matter what. So if one of them crashes or an entire server goes down, no big deal. The other 2 are still chugging along, handling all the requests. It's like an automatic built-in safety net for your application. All right, you did it. You're live. People are using your app. It's a success. And then it gets really successful. The floodgates open. What on earth do you do when you go viral and the traffic just explodes? No, really, think about it. Thousands of users are hitting your site every single second. Your database is probably on fire. Your servers are melting. And all your brand new users, they're just seeing error pages. So what's the weak link? What breaks first? Yep, it's that one lonely server. It just gets completely crushed under the weight of all those requests, and it goes down, taking your entire application with it. So the solution is actually pretty simple in concept. You just add more checkout lanes. Instead of one server trying to help everybody, you spin up a bunch of identical servers. Then you put a load balancer in front of them to act like a traffic cop, directing each new user to the next open lane. The workload gets spread out, and everything runs way, way smoother. But here's the thing.
You do not want to be the person waking up at 3 a.m. to manually add more servers. That's where auto-scaling comes in. You just give the system a simple rule, just like this one. It basically says, hey, if the average CPU load across all my servers climbs past 70%, just go ahead and add another server for me. It's like a thermostat for your traffic, automatically kicking in to keep things comfortable.
Okay, so surviving those big traffic spikes is one thing, but staying live for the long haul, that's a different game. It's all about building a service that's not just reliable, but also efficient, and it doesn't cost a fortune to run. So let's talk about a few pro tips for the long game.
First up is a health check. Think of it like a routine doctor's visit for your app. It's just a special URL, like /health, that your system pings every few seconds. If it gets a good response, great, the app is healthy. But if it reports back sick, maybe it can't connect to the database or something, the system automatically takes that sick server out of the mix and replaces it with a healthy one. It's all automatic.
Next, you need rate limiting. This is basically the bouncer for your API's nightclub. It stops any single user from totally hogging all the resources. You just set a cap, like, hey, nobody gets more than 100 requests per minute. This keeps things fair for everyone and protects you from all sorts of stuff, like runaway scripts or even malicious attacks.
Oh man, caching. This is an absolute game changer for both speed and your wallet. So look at the before state. Every single user request is pounding on your expensive database. Not good. But after, we slip a super fast, super cheap little memory store, a cache, right in front. Now, when someone makes a common request, we just serve it instantly from the cache. The database never even knows it happened. It's way faster for your users and way cheaper for you. A total win-win.
And here's another clever little trick, request batching. Just think of it like carpooling for your API calls. Instead of sending, say, 10 separate calls to your database one after another, you just wait a fraction of a second, bundle them all up, and send them together in one trip. It's so much more efficient, it cuts down on costs, and it reduces the overall traffic on your system.
Whew. Okay, we've covered a ton of ground, from prepping your code all the way to scaling it across the globe. So the big question is, what do you do right now? Here's your action plan for your first week.
First, you need to be watching these vital signs like a hawk. P95 latency is a huge one. Forget the average user experience for a second. This metric tells you about the experience of your unluckiest 5% of users. If that number starts to creep up, it means a chunk of your users are having a really bad time. And of course, you need alerts set up for your error rate and for any time you fail to connect to your database or other APIs.
So here's your mission for this week, should you choose to accept it. Step 1. Get your app deployed to a staging environment. Think of it as a private dress rehearsal. Step 2. Get those health checks and monitoring dashboards we talked about in place. And finally, step 3. Try to break it. Seriously. Hit it with a load test, see how much you can handle before it falls over. This is how you find the weak spots and build the confidence you need to really launch this thing.
And that's the journey. We've gone from a lonely little app on your laptop all the way to a global, scalable service that's ready for anything. All the tools, all the techniques, they're right here, ready for you to use. So the only real question left is your code ready for the world?